So any part of fluid, fluid means gas or liquid, gains heat energy okay, very basic. Like anything gains heat energy, molecules become big layers. Molecules around
Sir,
it.
I can't hear that well.
Just 1 second. Okay, I will repeat what I said because I think voice was not okay. When any part of fluid, gas or liquid gains heat energy, it expands. Why it expands? We have already discussed this. Whenever any object, whether it is liquid, gas, or solid, when it gains heat energy, molecules become big. Yes, they start moving with more kinetic energy. They push the molecules around it and they go apart from one another. When every molecule moves away from one another, what happens? Overall object requires more space. So this is why why any object should expand when it gains heat energy. So when we are heating a fluid, any liquid or gas, we cannot heat the whole fluid at once. We obviously provide heat energy from one side, and that portion that gains heat energy directly from the source becomes bigger. Its volume increases, it expands. What happens if the mass of something stays same but volume increase? What should happen if mass is staying same and volume is increasing? So same mass has more volume, hence less density. Okay, so when same mass has more volume, it means it has lesser density. Lower density fluid always rises and gets replaced by comparatively colder fluid, because cold fluid will be denser and hot fluid will be uh, less dense, it will be lighter. So when two things are mixed, two fluids are mixed, colder when two fluids are mixed, less dense and more dense, less dense should always go up. You can do that experiment if you put some cooking oil in water, like a half cup of water, half cup of cooking oil. If you mix them and let them put them aside for some time, you will find out that the oil will go up and water will come down, because water is more dense than cooking oil. So that's why cooking oil will accumulate on the top. Two fluids, less dense, more dense, less dense always goes up. And it is true for liquids, gases as well. Liquids and gases, the both. Less dense goes up, more dense comes down. So lower density fluid always rises and gets replaced by the colder fluid. This sets a movement current in the fluid known as convectional current. Just 1 second. Okay, I will fix it later. I want to fix it in one line. Now, let's go back. When any part of fluid, or fluid means gas or liquid, gains heat energy, it expands. So same mass has more volume. That means now this portion should have lesser density. Less density fluid should rise up and get replaced by the colder fluid. This sets a movement in the fluid. Within the fluid, now molecules are moving from one place to another place. This movement has a name, and that name is convectional current. And remember, it is not that electric current. Current means movement. Okay? This is convectional current, which is used to distribute heat energy within a fluid. And this phenomenon is called convection. It commonly happens in fluid. Convection happens in fluids, liquids, or gases. Now, question. How can we set a convectional current in a confined space? Okay, if this is a container, and it has a fluid in it, fluid can be liquid or gas. How can we set a convection current? Answer. Method 1, method 2. No, method 1. And method 2. Okay, now see. What if I provide heat energy? Method 1 is provide heat energy at bottom of the space. So what we do is we put a heat source here. So this is heater. So what will happen to the air in the surrounding? What will happen to this air? This air will take heat energy. This is heater. This is heater. The part of the fluid which is very close to the heater will gain heat energy from the heater, expand, become less dense, and rise up. Okay, just 1 second. Okay, this portion takes heat energy, expands, volume increases, expands, becomes less dense, rises up. But fluid cannot leave vacuum in it. So what happens is colder fluid rushes to replace it. Now this fluid is going up, it is hot, which will gradually be turning into cold. Because it will be providing heat energy to the surrounding, and then there will be this movement which produces convectional current. This movement of fluid within fluid is called convectional current. This movement is convectional current. Now, what is the second method of providing energy? Setting convection current. Answer is provide a heat sink at top. Now, this is a new term for you. Heat sink. What is meant by heat sink? Anything that can absorb heat energy. You know, what is the heat sink in your home right now? It is your refrigerator. Because you can put a hot object over there, it can take heat energy from it and drain it out. Similarly, your AC, if you want to know the scientific term for your air conditioner, when it is cooling the room, it is a heat sink because it takes heat energy away from the room. This is a way of actually there's nothing cold. Cold is not a thing. It is just absence of heat energy. Very much like darkness is nothing. It is just absence of light. Similarly, cold mean absence of heat. So a heat sink means heat pump or heat sucker, something that can suck heat energy out, or cold source. This is a name that only people use if they don't know heat energy. Cold source. Source of cold means something that can absorb heat energy. Actually, technical names are heat sink, heat pump, or heat sucker. But for the simplicity, sometimes we use a cold source. For example, uh, and this is true for hundreds of students. I have asked this question to. If I'm in a live class and there are like 40 students in my class, and I ask them if you have an AC in your room, like normally there are 2 or 3 ACs in the room that I'm teaching in the school, that I ask them, why do we put ACs on the top? Why ACs are always installed near the ceiling, not near the floor? Secondly, if I ask them, where do we, at what position You have put an AC in your room, and they all say that AC is at uh, uh, it is closer to the ceiling than it is to the floor. Why? Is there a ritual over there, like, or is it pure science? Why do we have ACs near the ceiling? Answer is AC is actually not providing something in the room, it is actually sucking something out. So if we have a source that can take heat energy out, this is a cold source. So what will happen to the air around it? Air or fluid which is next to it. So this part of the fluid will give its heat energy to the source. So source will take heat energy from the nearby fluid. This fluid will become colder. Okay, what will happen if if something becomes cool? Okay, kinetic energy decreases. Yes, speed of the molecule decreases. What happens to the intermolecular space? That decreases as well. If all of the molecules have come closer, what should happen to the volume of the object? Hmm, it decreases. Oh, that means this is called thermal contraction. Things are squeezing because they are losing heat energy. Okay, this is thermal compression, or in simple words, it is um, increase of density. Volume is decreasing, something is contracting. So when something contracts, mass is same, volume is less, so it means it will have more density. So this should sink down gradually. It will be losing its heat energy. Oh, sorry, it will be gaining heat energy from the surrounding. So, so this is how we can set another convectional current. This is also convectional current. So there are two ways we can set convection current in a fluid: by putting a cold object at the top, or we can put a hot object at the bottom. Where do we have a heater at home? If you have those convectional heaters, if your house is centrally heated, and you have those convectional heaters that are installed with the walls, that white color convectional heater thing, you will find them near the floor. Why? Because when they provide heat energy, it automatically spreads in the whole room. And when we put air conditioners on the top, they provide cooling, and that cooling spreads in the whole room automatically. We don't need to mix the cold air with the hot air. The cooling will automatically come down and spread in the whole room. And if heater is installed at the bottom of the room, heat will go everywhere in the room automatically. So that there are two ways to set a convection current in a fluid: by providing a cold source at the top or a hot source at the bottom of that confined space. Convectional current in normal life, just 1 second. Just one second. If this is the
Sir, we can't hear you.
okay. So this is sun in the daytime. So it will be throwing heat energy on the water as well as on the sand. And this is moon. And this is night. So at the daytime, it like listen, water has a very high specific heat capacity. It's not easy to change the temperature of water, but sand can easily be uh, heat up and it can easily be cooled down. Water hardly changes temperature, but sand heats up to a higher temperature than water. So if there's a person standing here, if there's a person standing here, because sand is hot, so air over here will be rising up. So what will happen is the cold air from the sea will rush towards the person. So when you go to beach in the daytime, you receive wind coming from the sea, because when there is more temperature on sand becomes very hot. Air on the top of the sand rises up, and it is replaced by the colder air on the top of the water. So when we go to beach in the daytime, in the sunshine, we receive wind from the sun. So from the ocean, from the sea. Okay. But what happens in the night? Water's temperature hardly changes as it has a very high specific heat capacity, but sand cools down to a lower temperature. When I'm not saying low temperature, I'm saying lower temperature. I'm comparing its temperature to the water's temperature. So if there's a person who has come to beach at night, so this person, because now sand is very cold, or it is cooler than the water. So what will happen is the water on the top of, sorry, air on the top of the water will be rising up, and wind from the beach will start going towards the sea. And this is what makes people fear the fear the ocean at night, because there's a wind going towards the sea, and they feel that something is pulling them towards the sea. Okay. And actually, this is nothing, just physics, because water hardly changes its temperature. I hope you remember. I was telling you that we are not very good judge uh, of temperature. And
Yes.
I had this conversation with many people, very smart people even. They believe that in summer, the underground water in Pakistan, we extract water mostly from the ground. Okay, in remote areas we put holes in the ground, and then we suck water out of the ground. And everybody believes that water becomes cooler in summer, and it becomes hotter in or warmer in winter. And I keep on explaining this thing. I had this conversation like in last, you can say in last 30 years, I might had this conversation over 100 times with many people. And I try to convince them that the water hardly changes temperature. And number one, it is water. It's not easy to change temperature of water. Number two, it is underground. Ground is a very good insulator. So there's no reason for the water to change temperature. Then they say that why do we feel water is warmer in winter and why it is cooler in summer? And answer is very simple. In summer, the temperature in Pakistan goes up to 45 to 50 degrees Celsius. 45 is very common in most of the areas. So 45, and you're extracting water from the ground, and that has a temperature of 25. So how do you think you will feel something that has a temperature of 25 when everything around you is 45? You think that it is cold. Actually, it is not. It is 25 degrees Celsius. But because our precedent has changed in summer, everything is very hot, 45 degrees too hot. and 25 feels very cold over there. So we feel that the water that is coming from the ground is very, very chilled. Opposite. In winter, temperature falls to 3 or 2, sometimes 0 over here. So if temperature is 0 degrees Celsius, and we extract water from the ground which is 25 degrees Celsius, everything around us is dead cold, and there is something which has a temperature of 25 degrees Celsius. What do you think we will feel about it? So actually, the temperature of the water is not changing. It is the temperature of the surrounding that changes, and that makes us feel that in winter, water from ground becomes warmer, and in summer it becomes cooler. But actually, the water has the same temperature. Similarly, over here, water is having same temperature day and night. The thing that is changing is the temperature of the sand. Sand can easily change its temperature. So when sand changes temperature, and in night we have wind that flows from sand to the water, and at day we have a wind that flows from water to the sand. Hope you understand.
Yes, sir.
Any
Yes.
confusion? Any question?
No.
No, sir.
So we will resume from the same point tomorrow. Thank you very much.
Sir, can you please send me the
Take care.
notes
Allah
for
Hafiz.
this chapter?
Yes, sir. Me too, sir.
Actually, I will send the PDF form at the end, but I can send you the images of today's and yesterday's lesson if you want me to.
Yes, sir. Can you please send
Yes.
them?